Hi, I'm Vasuki, working in L&T for the last 2 years as a senior architect, and my scope of work is more on towards green building facilitation. If you see, people are more aware on energy efficient buildings these days, and even green building rating system specifies on it, and we have large number of points for this energy efficient buildings, say around 10 points for LEED. And what generally we tend to do is we put up cost on MEP segments, say high efficiency chillers, VFDs, heat recovery wheels, overdeck insulations. And my point is, why should we increase the thermal load into the buildings and then try to bring down the cooling load? Instead, of course, we are going for insulations and high efficiency glass, of course, but are we using the glass effectively? If you ask me, I'll say no, it's not, because what we do is we generally follow the standards blindly what is being specified. Say in ASHRAE they say for U value around 6 and SHGC say around 2.25, and we blindly follow these standards and incorporate them in our design. But how to make it more effective is one has to understand the property of the material. Say for example, a high efficiency glass is more effective only it is when it is exposed to the sunlight. It is not effective when it is under shade. It is very equal to a normal glass. So what we can do is we can probably simulate the building in a software and find out the surfaces which are prone to shades and which is the critical surfaces that is exposed to sunlight throughout the day. For example, we might feel that the western side is more exposed to sunlight, say that to in the critical part of the time, say 2 o'clock to 5 o'clock. But if in case there is a building adjacent to it, this adjacent building could cast its shadow on this western facade. So going for a high efficiency glass on this facade is totally is not necessary. Instead, you can identify the critical surface and try to go for a high efficiency glass over there, and the areas which have been shaded the facade, you can go for a normal glass. That will do. And one more thing, it's not only in terms of facade but also on the floors. Say the lower level of floors, say ground, first and second floors, are more the impact in sunlight. If you see, it's not directly entering to the building. We have a adjacent landscape. It is influenced by the microclimate basically. So you can again work out in terms of floors. The lower level of floors you can go for a normal glass or a low efficiency glass, and higher floors which is exposed to the direct sunlight, you can go for an high efficiency glass. And the best thing is instead of reducing the instead of going for a glass with a lower U value, you can concentrate on the glass with a lower SHGC value, because SHGC, what it means is, it is directly it's like U value is like it works on the conduction heat process, whereas SHGC is like the direct thermal say sunlight and sun heat entering into the building. So to lower the SHGC, again you can go for glazing with shading devices. If you ask me, a glazing with a appropriate shading device is the best solution for a good envelope design. Say if your corporate design demands a glazing without shading devices, probably you can resource your glazing so that the thickness of the wall will act as a shading device. It's better than not providing a shading device at all. And again, for window wall ratio, instead of going for a high window wall ratio, you can reduce your window wall ratio so that a low efficiency glass itself will be much better. Again, say a simple thing like the higher your window wall ratio, the higher has to be your glass efficiency. Lower window wall ratio, the lower has to be a glazing efficiency. And again, for shading devices, say we can follow thumb rules, like for eastern and western side you can go for horizontal fins, and for northern and southern side you can go for vertical fins. And again, if you see this fins distance, that is a projection, it is dependent on the distance between the fins. Say if you the more you reduce the distance between the fins, the projection can be reduced.